All right, welcome to the second lesson in this KineFX 201 series. So now we're going to start building some of the actual controllers that we'll use to manipulate this rig. If you didn't see the first video, you didn't really miss anything crazy. You just missed some setup of like some rest transforms and some basic like groups and some attributes that we might use later. Nothing crazy. You're not going to need any of that info to follow along with these tutorials. So let's get into building some controllers for this thing. Okay, so we're going to be working on the animation side of this FBX. And the idea here is that we want to create some controllers in a packaged kind of node that we can stack. So like, just for example, let me say, oh, what, that is not what I wanted. Subnet, there we go. So let's call this control IK. And then let's do another one, like this would be control dynamics. And we could like layer these. So you could like add dynamics, and then let's say someone wanted to move the head or something like that a little bit farther in one direction afterwards. So then you could just do control IK, and you could kind of stack these things. And the idea is to create kind of simpler controls that do specific things. One thing I've noticed in my experience is that people don't tend to really like HDAs that have all the bells and whistles inside of them. Because usually with those HDAs, they're just full of parameters and UI and controllers. And if you're handing it off to somebody else to animate, it's a lot for them to take in. It's a lot for them to learn. And typically you want to just have controllers that do specific things that you can then kind of layer together how you would want to set them up. So when I build these controllers, I don't actually work inside of a subnet to start. I typically build them just open in this area. And then once I'm done and happy with the results, then I package it up and build all the UI. And we will build a few different controllers here for some different things. So the first controller that I want to build is just a general master controller. And I want this to pretty much be just like your general full body IK controller. However, we're going to make it a lot better than just a standard FBIK setup. There's a lot of little tricks that I like to do to make it make life a lot easier when you're working with them. And we'll run through all of that. So let's get into it. The first thing that we actually need to do here is, if you look at this, there is no root joint. There is a hip joint here, and we're missing a root. And when I'm animating a character, I don't like to animate with the hip as the root, because I like to be able to animate the motion. I like the general overall motion of the character, like say he's walking forward. I like to have that as a joint that I can control, and then I like to leave the hip alone so that I can use the hip to like control up and down or like crouching or different things you might use a hip for. So let's build out a root joint. So to start, I'm just going to drop an add node, and on this I'm just going to create a point, and then we'll do a rig doctor. I'm going to call this root R, because I know there's already a root M on this rig. So, okay, so that's cool. And then we're going to merge this in with our skeleton. And like in the last video, the way we merge this does matter. So I'm going to make sure that I merge the root in first. So it's the 0 joint. I'm also going to use a rig visualize to make sure that our rotation order is correct, or at least in line with what they're doing on the rest of the rig. So it looks like the rest of the rig has a rotation order of X and then Y, Z. So it's like looking down X, and then it's looking up is Y, and then out is X. So let's go ahead and make sure we have that right. I'm going to drop an orient joints node. Now on this, I want the reference vector to be the X, and then I want the up vector to be Y. That's not giving us, I'm going to hide these real quick. I'm also going to give it a color, just so this is easier to see. So color, and then I think these are just green, yeah. So I think we need to flip it. So -1, so it's looking down negative X, and it's looking down at Y. So now you can see these two orientations, they match. Not always a huge deal, but good practice to make sure, that's great. Good practice to make sure that these are oriented in a similar fashion. All right, I'm back, and now what we need to do from here is we need to parent this new root that we just made. We need to parent it to the hip. And I mean, that's pretty much it. I guess there actually is one more thing that's going to be important, is that we actually have to, we set a rest transform earlier with the rig stash pose, and since we added joints here, we actually need to reset it. So we're going to do a rest transform, and then we also want to clear existing attribute so it doesn't mess anything up with where it thinks that it's, so it doesn't mess anything up with the existing rest transforms, and we just replace it from the get-go. Okay, cool. I'm gonna make some more space for myself down here, and I'm gonna make a null. All this starts controller building. Okay, so now let's drop a FBIK node, full body IK, and I hate that so much. But okay, let's plug this in, and if you're familiar with the first series, you've seen these full body IK nodes before, and really, I mean, it's just a general full body IK solver. I don't really know how else to explain it, but we need some better control points because we don't want to use all of the points as controllers, and that's why we created these groups. So let's grab that FBIK group, and generally the FBIK group that I make is usually just the lower limbs, like the feet, hands, head, hip, and tail. You can throw the knees in there also, but this is a good base for some good interpolation. And let's plug that into a rig pose. And now you can see we get our we get our standard full body. We get what we expect basically. So that's cool, but it can be a lot better. And it can be a lot better in several different ways, but the primary thing we're going to be doing here is going to be leveraging parenting constraints. And while I'm on the topic of parenting constraints, I do want to show you there is a few ways we can blast these out actually. So if I did a delete joints, and then I set up our FBIK, you'll see that it does a similar thing, but it keeps the parenting hierarchy intact. Now, sometimes we want this, but it is a little bit slower than a blast node. And that's because it has to go in here and has to do all this extra stuff. And for what we're doing here, we want to optimize speed as much as we can since we're going to be stacking these controllers. Every little bit can add up if you're stacking like 15 or 20 controllers at a time. So wherever we can get performance optimization, we want to do it. In fact, there's actually a faster way to do it than the blast, which is we do a wrangle node, and then in here we basically just go remove point, and then 0 at pt_num, and then we also want a 1 at the end. This 1 is telling it to also delete the primitives, so that's need that in there. And then so this is going to delete everything, and on the group all we got to do is we got to do star caret and then our group, and now we have our points. And if we want to go even faster, we can compute results in place since we're not moving anything. So this is about as fast as you're going to get it. Wrangles and VOPs are usually the fastest thing in Houdini just because they're multi-threaded and they're set up to perform real well. So in this situation, we actually will be using this little wrangle here. You have other options. The blast node and the wrangle are very close. They're not really that far off. So in this situation, you probably won't even see any speed difference, but maybe on a very complex rig, you can cut corners wherever you can. It's nice. Call this delete all but FBIK. Okay, so now let's actually set up some parenting. So first thing we want to drop down is we want to drop down a parent joints node, and we want to set up a few different parenting types, and we're also going to throw a switch down here so we can switch between them. The first one, I'm actually going to just use an add node, and what we want to do here is we just want to delete everything with the points, and you don't really see any difference here because they're already gone, but if I was to say plug it in here, you see we're removing all of the connections between the joints. And that basically just makes it not constrained to anything. So I just call this one free, and I'll probably plug that in as the first input. And then this one, let's do the head and the tail. Also a little tip, when you're dragging these and selecting, if you want to get rid of this without hitting escape and enter again, hold control and then click on the joint that is currently selected. Okay, so this is just going to be the hip to the head, and when we use this, we can get controls like this, which is kind of cool. It's nice. We can do a few other setups as well. So I'll drag this out, and then on this one, I'm going to parent the head to the wrist. And now if I use this, so now the hip controls the head, and the head controls the hands. So that can be pretty nice. I also like to have a just standard forward kinematics one. So I'd take it and I'd basically go root, and I would just kind of build this as if almost I used that delete joints, so that all of the hierarchy order just goes in the same direction. And that's nice. A lot of time I don't actually like this one for full body stuff because of the feet, but you might want it for if he's jumping or if he's doing something along that matter. So it's definitely nice just to include it. So these constraints are cool, but let's build some ones that didn't already exist on the rig as well. So currently we're just basically reparenting stuff in a unique way from the incoming rig. However, we can make new joints and then parent those joints how we see fit, and then really leverage those points also. So for this example, and something I'd probably do anyways, I'm going to make a joint that connects both hands together so that I can move both hands up and down at the same time without having to move the neck or head or hip or any of the other joints. There's two ways we can do this, and I'm going to show both. First way is a workflow in SOPs that gets the job done, but it's a lot faster if we do it inside of a rig attribute VOP. And I'm going to show you the SOPs workflow first because it's a little bit easier to understand what I'm doing. And then we're going to bring it over and do the same thing a lot more efficiently inside of ops. Okay, so the first thing we have to do is we have to isolate the hands that we're going to be working on. And we have a group for that. So I'm going to go ahead and I'm just going to blast the root hands, delete non-selected. So now we just get these 2 points. I'm going to make some room. And now I'll do an add node. I'll go to by group. I'll make sure they're connected. And then I'll do a resample. And there's lots of ways you can do this, but ideally I'm just trying to get the point in the middle here. And you could do this by averaging. You could do this a lot of different ways, but I'm just gonna Houdini. You can do it a lot of ways. So the resample, and now we get this middle point, and we can get that point several ways. Probably the easiest way to do this, honestly, is just 0, 1, 2. So I'm just gonna blast out our 1, I guess, and there we go. There's our point. And then now we need to make sure that it has name attributes and transform attributes. And actually, it already does. So we need to get rid of them first. Because when we did the resample, it basically pulled over one of the names and one of the transforms from the initial points. And we already have a wrist L inside of our rig, so we can't bring this back in and do anything with it because it needs to have a new name. So probably the cleanest way to do this is just delete everything and then do a rig doctor. And now we can initialize transforms and initialize names. Because if we didn't have this, and I need to replug it in. There we go. So if we didn't have this attribute delete, then the rig doctor wouldn't actually create any new names because it already exists. So we need that attribute delete in there. And then rig doctor sets up our names and our transforms. I'm going to call this control hands, give it the color. And then I should be able to parent this back in, merge this back in, and then parent them. So now I can go and I can parent the new control joint to where the hand joints were originally parented to. So now we have a pretty cool controller here where we can, one more thing, actually. So we get this big error that pops up, and we're getting it because there is no rest transform on the joint that we just created. So go away. We need to make it. So we'll do a rig stash pose, and then I'll do clear transforms, and then I'll just plug it in there. And now we have our rest transform, and it's not yelling at us anymore. It's cool. So now I can move this guy around, and I can still move the hands around, and I can move the head around, and everything follows the correct order. All right, cool. So now let's make this setup inside of a VOP because this sucks and I hate it. So let's do it. So I'm just gonna basically delete everything that we have except for this rig pose. You can stay, and let's drop a rig attribute VOP here now. So now we need to go inside of this node, and we need to do a few things. First thing we need to do is we need to get the group or the points that we want to create a new joint in between. So we can do that by a node called get transforms or get point transforms. Now there's get point transform and get point transforms. The plural version of it returns an array. And if you don't know what an array is, I'm assuming not all of you are techie people. This will get techie at times. But just in case you have no idea what I'm talking about, I'm going to plug in a test parameter. You can see what's happening here is it's returning almost a list of the point numbers on this. So 0, 1, 2, 3, 4. If I was to plug in the x forms, it's a list of the x forms on these points. Now, we can get these elements by get array element, and then if we plug in the array, and the index corresponds to what we're returning. So you can see we have 0, 1, 2, 3, 4, 5. I'm going to do this on something that's not so straight line, which will be our hands. So we'll do root hands. And you can see we only have a 4 and a 5 in here because those are our hand joints. And now if I was to do get index 1, then we get 5. If we do index 0, we get 4. So I create 2 of these guys. This will be index 1, this will be index 0. And then we need to get the position of them. So I'm going to do input point attribute, or import point attribute. And we'll plug these in to the point number because that's what it's returning. And we'll do input is the first input. And by default, these things come in with the attribute p, which is actually what we want. So we don't need to change that. We'll just drag one also over for the second. And then we're just going to average these together. And that average is going to be our new joint. And we're going to use a node called add joint. And it expects an x form, which is a matrix. But you can actually plug in a just vector, and then it'll work just fine. The reason we're not doing get point transforms here and then averaging those is because averaging a matrix can get very sloppy and can get very messy. And it's just a road you probably don't want to go down when this works just the same. And only thing you're missing out on is rotations, but it might be a good thing just not to have those anyways. So we're missing a few other things here now. So we have this, and let's name this control hands. So the things we're missing is we're missing a rest transform, and we're missing, and it's not as important, but we're also missing the color. So let's go ahead and get both those things. So let's start with the rest transform. And if I move over here into the geometry spreadsheet, you can see it's a 4x4 matrix. And so let's go ahead and set that attribute here, and we're going to call it rest transform. Also a heads up, since rig attribute VOPs and some of these VOPs run detail, they run over detail, so they only run once. Binds don't output to the point context. Instead, a bind would output to the detail context. So the way you need to set attributes on a point is with this node set attribute. And for this, we need to have the point number and the value, and we set all the attribute and name stuff up here. So the point number is actually going to be the point number we're getting out of this add joint. So we'll grab that guy, and then we want to make sure that this is a matrix attribute. And the value here, we can't set it from this average because this is a vector. So we need to convert this into a matrix. An easy way to convert it into a transform matrix is just to drop this node called make transform, and we plug in the translate, and then we're done. And now we have our rest transform on our new joint. Let's do the same kind of method for the color. So I'm going to do an import point attribute and plug it in here, similar to how we got the positions that we averaged between. I'll do first input and CD, and then we'll do a set attribute. So it'll be a vector, be CD, and there we go. Now our point is all green and nice. So there's a few other steps we can take to make this a little bit cooler. And first one is to set up the parented constraint. So an easy way to do that is we take our incoming points, and then we do this node called get parent. And all it does is it takes the point number, and then it takes a file. And I also want to show this real quick. I have hotkeys to drop bind nodes, so if you're wondering, I just dropped that. Anyways, so let's call this test, and then let's look at the detail attribute. So this is going to return the point number of the parent joint. Now, if we don't have a parent joint, it's going to return -1. So this is very common in inside of ops. If you're working with integers and stuff, if it doesn't exist, it's probably going to be -1. So just letting you know how that's working. And all we have to do really here is plug this into the parent input on the add joint. And if, for example, we didn't have one, it would still work fine because we're returning -1, which would tell it there is no parent. Now let's take it actually a little bit further and make this setup into basically a tool. So if we go to group, we can promote the group name that we're using. And then we can even actually do some sort of offset to this transform. Like you might be able to do it right here. Nope. So we can do, let's do a add, and we'll remove that parameter, and we'll go offset p. Make sure that's a vector. All right, cool. So now we can actually push it up. Should be able to. Okay. Yeah, we gotta set it into the add joint as well. Okay. So now we can move this. For example, if I wanted this controller to actually like be above the head, we do that. And now all we have to do is we just have to reparent these joints here. There, I'm just gonna. Actually, I think unparent on cycle works for this. So let's see. Yep. So unparent on cycle. That's basically you can read the help. I'm just gonna tell you the same thing, but basically, it'll unparent a joint if it's already parented to something else whenever you're setting any constraints here. So cool. Now we have our hands, and the cool thing about this setup is that we can actually change this. So we can do root feet. I believe that was our group. Root. Let's see. I don't think I actually have root feet in here. What is? Well, let's assume I did. So I don't know what ones root feet were, but let's just make a group. Let's call this root feet. There you go. Now we get our setup. We also could probably promote the name of this thing. Okay, cool. So we can change the name. We can do all sorts of fun stuff here. But I am going to put it back to the root hands that we just did. I'm also going to delete this group I made. So cool. Maybe is that 10? All right, let's. I'm gonna do 2. That feels right. That feels right to me. Okay, cool. Let's move on a little bit. I'm gonna keep showing you some more ways we can make this full body IK setup better. So now let's talk about how to get this tail to not look terrible. By terrible, I mean when you work with tails inside of an FBIK, it usually does some weird stuff like this, and it also just doesn't really look very good. Usually, it doesn't interpolate well, and so you see we have both influence with our position of the tail and our rotation of the tail. It tries to match the end rotation of our joint here. Now on the full body IK, if I drop down this configure tab and I hit this plus, then we can start listing off some configurations. And inside the group here is where we're going to put our joint that we want to configure. And it's also important to note that this joint has to be on this side of the FBIK node. It has to be a controller. I mean, it doesn't have to be, but it's not going to do anything if it's not. So instead of selecting, I'm actually just going to put in my tail group because I know that this thing is in there. And on this now, if I say type set to position, it's no longer going to care about our rotations. So you can see I rotate this. It's not doing anything. It doesn't matter. That is okay, but I actually like orientation better on this node. So now it's the opposite of that, where moving this thing does nothing, but twisting it gives you actually a pretty nice interpolation, and it's pretty easy just to kind of wag this thing around. So that's how I like to set up the tails on here. And let's also introduce our, let's see, in lesson 1, part 2, we made this rig-attribute collision setup, and I'm just going to copy this and paste it, and I'll put some sort of floating YouTube thing with a timestamp for the video where I go over this. Basically, we created an attribute, and then we're using that to drive the distance on a collision applied geometry node. And so now we can plug this guy in here, and now these feet can't go below the ground. So cool. All right, so now I want to show you, it's a node that I made that I'll also include with like the 50 other ones I'm apparently including in the description to this video. But I'm actually going to dedicate a whole other video to explaining how this thing works, because it's very, it can be very confusing and complex. And I don't want to make this video like an hour long. So I'm going to just put this in the setup for you and show you what it does, and then I'll explain it in another video. So this node is, I called it Easy Rig Pose Space Switcher. And this is essentially a rig pose node that gives you the option to switch spaces and work with both of them. And what do I mean by that? So you have spaces inside of a rig pose. So if I drop a rig pose and I start working with this thing, you can see this joint affects the next joint and the next joint and the next joint in the chain. If I switch to world space, then I can move this joint independently without moving any of the other joints. And it's nice, but when you switch back and forth between these things, you get very different results. So like A being it, you can see the issue that we have, obviously, especially if you're animating on it. And then also if you're stacking these, so you're doing one after another, then one way it's going to heavily affect the next, one of these rig poses is going to heavily affect the next one. So removing an adjustment or a keyframe could really kind of mess up the whole sequence. So what I did was I made a node that essentially it's using a skeleton blend to merge two rig poses and then also simultaneously get the correct handle offsets and the correct visualization. There's also some fun little Python stuff up here. So like, for example, I'll show you one. If you hit this populate joints button, it's going to populate all of your joints that exist on here on both the local and the world tab. When you switch from world space, you can see it switches the tab for you, just so you're not confused. There is other settings. So there's this focus mode. If I was to click a joint, let's click this, you'll see that it becomes highlighted and it becomes in focus in our view. You can also do filter selected parameter, and now it's going to isolate just the parameter that we have selected. I'll turn this back to the defaults. There's also some other settings in here, so you can scope all. I don't know if you are familiar with scopes in Houdini, but if you see, for example, you see how these lit up colors? That means it's scoped. And when it's scoped, that means that you have it in your, that means that you have it inside of your animation editor. So that's nice, because when I hit this auto key button, it's going to drop keyframes on whatever is scoped. And also, you see the keyframes down here. And see now if I select something else, you see you don't see the keyframes anymore. If I click on this again, it scopes it and you do see the keyframes, and we can drop keyframes. Now, if I just delete those keyframes and now I scope all, you'll see that all of our translate and rotate parameters become scoped. So I can easily set a keyframe on all of the joints that we have here. I also could just scope the animating, and I can also clear the scope, and that just removes everything from the scope. Set values to default is just going to set all the values of the, like if I move this, it's going to set this back to 0. You could do it on a keyframe, or you could do it just setting values. And let's go ahead and I'm going to clear joints, populate joints again. All right, so what does this node really do? Sorry, I got carried away with the buttons. All right, so there's this world space button, and basically it switches modes for you. So not in world space, I can move the hip. And then if I click world space, you do have to deselect the joint, because when you switch it, the joint doesn't necessarily switch. So you have to deselect it, select it again, and now you have your not world space, our local, actually, no, this is world space now. And then just to go back, I have world space off, and it's going to record the translate and rotates on both of these. So you can animate the local and world space simultaneously, and because it's not being run one after another, it's being run through a skeleton blend, and they're being blended together. We don't have any weird effects from animating these things together like we would with stacking rig poses. So this node I actually think is very nice for just setting up quick poses. Like if I wanted to, just set the head, put the hands up. Actually, I'm gonna pull this guy up a little bit more maybe. Okay, the hands. And then I can just work with the world space. So say I wanted him to look up and then turn his head real quick without moving the arms and everything, without having to jump back and forth between two different nodes animating. So this is very nice. And I probably will include this guy inside of the controller just because it's nice.